My slides may freeze. I'm not sure. Sometimes it happens on Teams. So let me know if the slides are not moving. Huh?
Sure. Yeah.
All right. Okay, then let's start. Hi. So as we said, I'm Tushar. So I'm currently an applied scientist at Microsoft, India Development Center in Hyderabad. And so I'm currently working on graph intelligence with the knowledge mining team. So it's mainly about learning from data which is represented in the form of graphs. Example, the emails you send, the files you work on, everything is connected as socially connected graphs with the heterogeneous entities such as what do you say, people, files, meetings, many more. So our job is to basically learn information out of these large graphs. So before joining Microsoft, I was a research scientist at a startup in Berlin. So very short stint in Berlin in Germany for 6 months, where I was working on privacy-aware machine learning, mainly federated learning and similar stuff. And before joining the startup, I was a postdoc researcher for 2 years in the University of Edinburgh in Scotland. So I after completing my master's and PhD from IIT Guwahati in 15 and 19, so I straightway went for my postdoc in the University of Edinburgh, where I spent like 2 years, a wonderful 2 years in actually in Scotland. And there's some other information I'm going to give here. Like I finished my undergraduate in 2013 from like low tier college nobody knows about. So my main point, on spending some a few minutes on this slide was to not tell you what, detail about what I have been doing and what I am currently working on, but mainly about, the steps I took from like 2009. I joined my undergraduate, and 19 after 10 years, 11 years. So I finished my study and then move on to postdoc, which is mainly still research and not an actual job, you can say. So the point here is that uh, you know sometimes it takes you, it may take you more time to go to, achieve your goals, or, for example, you want to go from A to B. So it may happen that, in one shot you got to B, but maybe sometimes not. So the idea is or the point here is to, take a alternate route which makes you closer to B. So you can go to A to C and then C to B, but of course be a vector. So have some direction, and then, going towards C would be would be, would be beneficial to you in future. So just wanted to share these 2 points with me because like a few years back I was on the other side and was listening to one of these talks during my, academic days in IIT Guwahati. So yeah, this is one point I wanted to make, for the students, especially now during the, the Corona times. So these are challenging times, and I think the batch coming out will be very mentally strong. So I think many of the companies will be, willing to take students like this who have gone through such challenging times and still, working hard and attending such talks. Yep. So yeah, thanks for listening me for these few minutes. I will get on to the main uh, theme for today. So yeah, today I'm going to talk about privacy-aware machine learning on the data you cannot see. So it's a simple, as you can see from the title, it's basically about, how to learn from data which you are not allowed to access, or basically you cannot, do some kind of printing on them, or you cannot debug it directly. And if you think it, give a few seconds, like how will I debug if I cannot see, or how will I learn from something which I cannot have access to? So that makes it, you will feel it very challenging. So before introducing you about or giving you an overview, let me give you an example of in one of the application which you may, or many of you may have used, called Gboard or Google Board. So while typing in WhatsApp or any messaging app, when you type a few words, it will give you suggestion. For example, here I have, I, and thanks. So 3 suggestions are there. So if you think about, how Google knows, how this application actually knows about, what's the next word will, or basically, if you think carefully, it may mean that it's reading whatever you are typing. So even if you write something on WhatsApp or any other app, and if you say the app is, secured, What about the Google board? How will you make sure that it's secure and not reading what you're writing? So what you're typing basically. So this is where one of the very what do you say an important application of privacy machine learning, where you have to predict your next word without actually seeing what you are typing. So let's see how we solve these kind of problems in machine learning domain. So what happens is that data is,
Sorry to interrupt, sir. Are we on slide 2 right now?
you see data on the edge slide.
No, actually, we are just seeing slide 2 right now.
uh,
The privacy awareness.
Let me, that's the thing. So I need to actually share my whole screen here. This is a, oh no, this is a bug. So were you seeing this slide?
Yeah, the slide 2 privacy aware. Yeah, this one.
All right. So let me again come back here. So this was the Gboard I was talking about. So for the Android users, I'm assuming that people still have Android, students will still have Android phones and not the costly iPhones. But at least in the Android phones, you have the Google board, and where you can, when you type a word, you will get an what do you say, suggestion for the next word. So these are the applications where you cannot say, hey, you cannot allow Google to basically read what you are writing. You may even sharing some some personal information. So how companies or apps such like this ensure that they are not reading your data but still fulfilling your experience. So that's the one of the applications of privacy aware machine learning, and we'll know more about this in the coming slides. Okay. So so now we have now almost everyone has a phone, and there are internet of thing and devices which are generating huge amount of data, personal or non-personal, not sure, but it could be both. And what we do is that this from this data we try to find out meaningful insights, or extract information fro- from the data. So when I say data on the edge, is basically the edge here is the other end users. So data is very close to us currently. Even if you are working on a on a PC or on a phone, we are generating a lot of data. And this is what, and machine learning is all about data. When you have data, you can learn something meaningful out of it. So data is currently on the edge, but how do you learn something meaningful? Be it to somehow tell or give or share this data to the companies or the apps to make meaningful model or meaningful reasoning about it. So what usually happens is that this data is sent to cloud somewhere far away. I don't know, maybe within Asia or somewhere in different continent. Your data goes there. Then there's a collection of data from all the users around the area, and then some pre-processing and processing happens there. Now, if a data leaves your phone, there is always a point of risk there. If it is with you when you're offline, then you can say, hey, it's with me, my phone. If my phone is with me, everything is secure and fine. I'm sure nobody can hack it down because it's not on the network. But once you start uploading your data, or apps such as Google board starts what do you say, extracting your information, and then running some processing on it, your data is on risk, your personal information is on risk. So the question here is, should data leave the edge? Is there any way where you can avoid data leaving the edge, and you can still learn, or you can still have Gboard like experience of prediction of words? So there was a survey done by Deloitte where 90% of consumers were found that they are accepting the legal terms and conditions without actually reading them. And actually, I think if the people who are attending this talk, if you think to yourself, how many of you have ever read terms and conditions? So I think, I'm not sure if there are many, but I have not seen many people around me which have actually read some terms. So because they are actually long. But if you actually have to happen to have read them, you will see that they will talk about data and what kind of third-party consumers can use your data. So many times you will see a line specifically written that we may share this data with our third-party trusted on partners. Now these third-party trusted partners, we don't know who they are. Everything's fine. Can you see my slide? Just to sanity check here.
Yeah, we can see
Yeah,
also.
yeah. All right. So yeah, so they will see some of these lines there. So that is where you actually accepting some terms, legal terms, and hey, I'm happy to share my data. And many times I've even heard from people that I am an open book, I don't have anything to hide, which is actually quite what do you say, amusing to hear. So you can always, so one of you can always say or counter to my, things that, hey, Tushar, like let's, where you're talking about, data uploading and, data is at risk. So there's a thing called anonymous, you can make the data anonymous, you can hide the names of the people, and still share the information. What is wrong about that? Everything is solved now. But many years back in 2006, Netflix actually released a competition where they shared a database, a huge database of which contains subscriber ID, the movie title, and the year the movie was released, and the rating the subscriber gave it. And then ask the contestant, hey, come on, use this data and you just what do you say, and see which of basically the develop an algorithm which can improve the accuracy by 10% on recommendations. Because if you happen to use Netflix, you can see the Netflix recommend movies actually quite well. So what happened was that after this competition was released, a few privacy or what do you say, crypto researchers, one of them is an Indian, actually backtracked or reverse engineered the data. So basically what they compared the Netflix review data with the IMDb data and other sites, and actually were able to reverse or backtrack the subscribers who rated them, which was a very a big privacy breach happened. So there was some complaint there, but still Netflix continued. And then in 2009, again they went with this what do you say, competition. But then there was a lawsuit happened. A lawsuit was filed by a lady who was supposed to be have some sexual inclination to, let's say, lesbian, and she was not happy with sharing the movies or this kind of information, which was very impersonal for her. And then the competition was stopped there itself. So even though Netflix is a big company and they made sure that data anonymity has been preserved, they must be having so many engineers working, and they must have showed, but still the few people were able to backtrack it. The point here is that anonymizing data is hard and it's not foolproof. So the question is that now should we discard the data? Of course not, because data is the what the electricity now, as according to Andrew Ng. So of course we can definitely use them to our benefit. So the point of discarding them doesn't suit. All right. So then what could be the solution? When I say, hey, you have the data on your phone, you can't upload it, it is risk. So what can we do now? How will you, learn these kind of, or make these kind of applications which help you without even seeing your data, without even accessing your data? So there's an alternate solution, and the term called federated learning. It has many other versions, like privacy learning, and there are many flavors of it. So I'll just go with federated learning because it's more famous, and if you search about it. So federated learning is one such paradigm which allows you allows such firms or companies or a user or a data scientist to learn meaningful models or information out of data without even accessing it. So for diving into federated learning, I just wanted to give one slide on basic neural networks or any machine learning model, what happens there. Just assuming that people maybe here are from first year, or maybe they are not from so much aware about machine learning. So what happens is basically machine learning is nothing about taking some inputs. For example, here the application is like there. Let's say there are three inputs: age, gender, and stage. And the output we want is that if I give you these three information, just a minute to raise a point. Yeah, if I give you these three information, what is the probability that the person is alive? So given the inputs, what basically we learn in machine learning is we try to learn this weights, the model weights, like what should be the number this input 34 should be applied to, so that the output becomes zero point 0.6 or higher than zero point 0.5. So that is what we learn actually in machine learning, the weights, the coefficients of an equation, if you talk about in terms of mathematics. So this is all about what do you say, at least for now you can say that this is the what we are trying to learn, this information or the weights. So input is given to us what we need, and output we is something which we expect it to be. It could be a label data, and this is what we need to learn, uh, this weights. So in other words, I can say safely maybe that weights are what basically the information which has been learned from the input. So when I say information, actually I'm talking about the weights deep down. All right. So let's talk back to federated learning, which is an alternate solution and it lets you learn on data which you cannot see or do not have access to. So what happens in traditional machine learning, which happens usually what is happening right now is that there are some clients, let's say mobile phones, and you are connected to some network, could be your GSM network or it could be Wi-Fi, and there is some far away centralized server which is collecting your data and some training is happening there. So usually what happens traditionally is your data is uploaded to a centralized servers and they are collected. Then all the users basically they are connected to this server through an internet connection and then they are uploading their data. Once you have this data collected in huge amount, you learn some meaningful information out of it, a model, and then you share this model back to these clients for on-device inference. And this is what happening with the Gboard. So even the new Pixel phones, the Google Pixel phones, the model is actually running on the phone. So that is what happens in Google board also that once you get this model, the on-device inference happens. That is, whatever you start writing, it uses the model information and gives you the next output of the word. So this is a traditional flow where data is moving actually in the servers. And of course, as I said, there's a risk here because we don't know who are those third party, and it may happen that sometimes there is a breach. So here comes federated learning. It's a different way of doing training, and you'll see the difference here that instead of sharing the data, we only share the model parameters here. So again, in the last slide, we are sharing the data in the traditional workflow, but in federated learning, what we share is the data, the model information. So when I talk about the weights, that was the information I was talking about. So what happens is there is training which happens locally on each device. Instead of collecting the data in a server and then having a centralized training, what happens is that each user or each mobile phone or a smartphone of a user, it does a local training round within its own environment or its own memory. So for example, let's say when you are conditions could be something, for example, let's say when you are charging your phone, the model training starts. So it basically starts collecting your data locally, starts training the model locally, again locally. And then when the time comes, it only shares the information out of it and not the data. So let's say there was a model M. After training, it becomes M dash and then it goes to the servers. And then from servers do something and it again sends back the M. But now this you can see that here's only one smartphone which is actually sharing the model. But with one smartphone, we will not learn anything meaningful. We need multiple data sources here, and that's where comes the full picture of federated learning happening in a distributed manner. So each phone actually shares a model. So, sorry, I'm sorry. So initially, what happens is that starting from the servers first share the initial model M with each of the phone. So that is constant for each of the devices. After some conditions are met, for example, the phone is in the charging dock. The each of the device does a local training and make the model and convert the model to M dash. So basically, each M dash is basically a new improved version of M. Now the server asks not the data but the model itself to be shared. Once the model is shared, the server then averages. You can do simple averaging or mean or mode, up to you. There could be different operators there. Once you do the averaging of the weight of the model, you can then share it the model update back to the devices. So you can see here actually that what is happening is that instead of now sharing the data, I'm only sharing the W parameters or the weight of the neural networks. So each device here basically trains the model locally on my phone, let's say, and the phone is only sharing the model parameters or the information and not the data or the raw data itself. So once these basically model weights are just the numbers, the floating point numbers, and these model weights once are uploaded into the servers, then we can do a simple averaging, let's say, divide by n, sum of all the weights parameters. You get another model out of it and you share it back to the clients. Now this happens repeatedly for multiple, iterations or, repetitions. Once you have a decent or desired amount of accuracy in the model. And it is as simple as that. That's all about the federated learning where, instead of data, you actually share the model information. But there is one more. There is a very big but here that you can one can always say, hey, you may be sharing, delta w's, which are again information, maybe not direct, but there is indirect information there. You can always trace it back or reverse hack it to know your raw data, or you can build your raw data again. And this is actually true. It's still possible to even after this, you can still possible to reverse track or reverse hack this data, raw parameters or raw weights into data. So are we secure now? The answer is no, we are not actually. There are still many things which happens in privacy aware machine learning. And so there could be as I said, there could be a curious server which can reverse hack the weights. You can always never trust the server. So there's a potential privacy of risk of leakage in here. And that is where another technique called secured multi-party computation comes to the rescue. So secure multi-party computation, or SMPC, is all about collaborative what do you say collaborative sharing of information without revealing the personal data. So let's say there is a given set of parties or players and who want to do some joint computation. So let's say there are three people, A, B, and C, and they want to take a average of their salary. Now this is a very simple problem. Three salarymen who wants to find out their average of the salaries, and without, of course, not revealing the exact salary, because of course, revealing salary is not very comfortable, and also many times gives a lot of judgment to others. So how can you solve this problem, taking the average of the three people without even asking their salary? So you can always say, hey, we can say that there is a person or a party you trust completely, maybe your best friend, and you can say, hey, we will only tell this best friend or salaries, and then this trusted party or friend will tell you the average. But again, we don't know. We nobody trusts. There can be a, what do you say, perfect trust, and there are always chances that that friend betrays and may really reveal the information. And that is where SMPC or secure multi-party computation comes here, where such trusted parties may not exist. So how can we do this? How can we calculate this average salary without revealing the raw information? So there's a method called secret sharing, which happens in privacy aware machine learning. And let's say there are three people, Ali, Brian, and Caroline, A, B, and C. And just for example, let's say we know, the salary of Ali is 100, Brian is $200, and for Caroline it is $300. So average here you can clearly see is 200. So what happens in secret sharing is these three parties, A, B, and C, they will randomly divide their salary into three parts. So let's say Ali divides the 100 into three parts, 50, 30, and 20. So this is all random. So next time you divide, you again it will be a random number. We don't know. Nobody knows about this division of numbers. So LA divides in 50, 30, and 20. And what it does, it very simple thing. It keeps one of the part, the three parts, one of the part with its himself or herself, and remaining two are distributed to Brian and Caroline, 30 and 20. So if you add them up, it is again 100. But Brian only gets one of the part here of the secret. Similarly, this is what Brian does for $200. So 100 minus 80, 180. Again, random. If you add them up, 180, 280 minus 80, you will get 200. So Brian again does the same thing, keeps one part of the data of the salary, and remaining are shared with other people. And similarly what the Carolyn does, 300 is divided into three parts, 0, 350, and minus 50. Now you'll say, hey, what is happening here? Everybody gets some part, but you can see actually there's no information leakage up till now. I only gave a part of my information to Brian, and Brian with getting number 30 doesn't know anything. Similarly, if it gets 350 from Caroline, it still doesn't mean anything. It's just random numbers for Brian and Caroline and Ellie. So once this division is happening, the trick is now happening. The magic now happens is that you can now ask each of these person who have these secret shares to sum them up. And so if you actually sum them up now, so now vertically going minus 30 for here, for Brian is 480, and for Caroline is 150. And now you can ask any third party, hey, now you can collect the data. So if I collect the data now and if you add them up, you will see the sum will be 600, and that is what happened. So average is 200. So I'll give you a few seconds to digest this. That even without leaking the information, you can still calculate the average by just splitting the data into secret shares. So why I explain this is that this is what is happening on top of federated learning. Many companies may employ these kind of techniques to actually also divide your weights into these kind of parts. So this is what completes federated learning in its whole domain. So so privacy aware machine learning is not just about, this is the one technique I shared with you. So it is not about just SMPC or federated learning. The point here is to make you realize that how can you so there is one more important aspect in industry, which is privacy. So for example, if you're an interview for a company, you can always say, hey, I given, or if an interviewer asks you like, okay, develop a model, this is the data. So you can always say, hey, I need this kind of information to learn this kind of model. But of course, in industries, for example, in Microsoft and Google, there we are handling so much information, for example, Outlook and your files, but that we cannot see, the companies cannot see your data. How can you learn models out of it? So this is a very challenging problem, and that was one of the motivation why I gave this talk, was to let let the students aware about this another aspect of machine learning and AI. So it's not just about learning from data and then modeling, which is totally happening now when you see YouTube lectures. But there are other aspects to it, which are privacy is one of them, which is so just to make you aware about privacy is a very important factor, especially now when people are becoming more aware, when government has are introducing new policies about privacy. So this is where this time is it's very hot area for what do you say, privacy or machine learning. So just to give you a start, how can you start about PPML, privacy preserving machine learning. So I'll just share a few resources which I have, which I have also personally used and was part of. So there's an open source organization called Open Mind, which work on developing and research about these kind of tools for to enable you to learn from data without seeing them. So I was one of the contributor for PySift, which is a library. It's a Python or based library. And one of the way you can join this organization is, first of all, going to this website, and then there is a Slack group out of there. So you can join the Slack channel, and there are a lot of opportunities there, from jobs to projects to the Google GSOC. They also participate in GSOC competitions. So it's a very good venue to start on privacy aware machine learning, and you will learn many aspects about many variations of federated learning and different forms of like differential privacy and other stuff. Another library which Google is also actively participated or working on is TensorFlow Federated. So they also have many lectures out of it. So it's also a good sort of resource you can look. uh, just to give you a summary, so federated learning is more about machine learning on decentralized data. When I say decentralized data, is about data which is distributed, or it's not centrally collected. So that's the whole gist of federated learning. And there are so the use of federated learning may come up when one is obvious, when you need privacy, and it may also come up when the bandwidth and power consumption are very important. For example, data is much larger in size than model parameters or model information. So transferring data from your phone, on a, let's say, on a GSM network, will take more battery and also will be more costly. But transferring small information still saves the power. Again, cost is another factor there. And if you want your model to improve with data, that is, you want to have a continuous learning there. So some of the examples of real world applications where federated learning been employed is, first is of course Gboard, which I explained before. Then there's a Chinese bank called company called VBank. So they use the federated learning to basically detect frauds. So many people actually, they take loans and they don't return it. So they may take loan from first of various banks, and then they come to another bank in the hope of loan. Since the bank cannot disclose information, the other banks cannot know if this guy is a fraud or not. So what the B bank does it that it allows multiple banks to actually share the information, look in a federated manner. This the way I have explained. So without revealing the raw information, they only learn the model, and the model tells if a person is a fraud or not. And it's a very ongoing project. You can have a look at it. Just search for VBank, and you'll know about how federated learning been used in the real world. So very good application of this kind of decentralized learning. And of course you can always of course healthcare is very important application, because health data, as you know, cannot be is a personal information, and very what do you say, we have to be very careful while sharing it. Mostly hospitals doesn't allow them. And yeah, so another is predictive maintenance, like in industrial IoT, where, like example, oil and mining industries, they also work on critical domains where they cannot share their data with their competitors, because oil is a very profit generating sector. So all these kind of examples basically tells you about that predictive learning is not just a concept, or privacy machine learning is not just a concept, but it's been employed in real world scenarios. That's all. It's a short PPT, but yeah, what my main aim was to basically make you all aware about privacy aware machine learning, how to go about different tools, and how can you start with that. Yeah, all right, so I may take any questions if anybody have. We have, I think, sufficient time. I see a couple of hands. Yep.
Yeah, Suraj, you can unmute yourself.
Okay. Thank you, Tushar sir, for this wonderful talk. So I had this question regarding that particular algorithm where you are sort of anonymizing the data. Is it that amongst the peers, at least we have to share the data, and for that, like when the peers share the data, can't then still we track the data, the source of the data, and the total value? I understand maybe that is just one of the algorithm, but similar algorithms do they share things amongst the peers?
Not all algorithms. So SMPC, I think you must be referring to multi-party computation, right? The example I gave about salary. Is that what
Yeah,
you are
yeah, but
referring to? Yeah,
yeah.
yeah. So a multi-party computation, as you can see with the name, it's a kind of collaboration with multiple parties. So it's not that every algorithm does that sharing of information, but yeah, with SMPC you have to do it. Uh, that's the way it works out. Because otherwise, one way is you employ your own what do you say, parties, which are other which are basically different from the users. You can do that, but it depends upon the company. But that's the concept here is that the parties can be anyone. It could be user or it could be third parties. That's fine.
Okay.
Does it answer your question?
Yeah, yeah, it does. Thank you.
Yeah. Yep.
So thank you, sir, for the presentation. I had this question that there are a lot of data sets about credit card fraud detection online, and basically, generally, what they do is they just blank out the columns of the data and
Mhm.
perhaps like perform some kind of transformations as well on the rows of data.
Yep.
So, like, so in those kind of cases, we do not really need privacy-aware ML. So exactly what is the like what are the kind of tasks where we can use it?
Yes. So you give me a very typical example, or very what do you say, a traditional example of when we how when we start learning about machine learning using these kind of data sets. So this is basically an offline environment you're talking about. Let's say download some data from Kaggle or somewhere, and then you just train a model. But the thing is, even if you learn, so this data set which was created, it was very old data, first of all. They may have ensured that nothing is revealing there, but this data is not constantly updated. It's still an old data. You cannot use it. So you cannot come to a, for example, you can't go to a bank and say, hey, now I learned a model on a data set which I got free from somewhere and use this model to detect someone is fraud or not. Because because with time, there are new customers coming, the data set or the database is evolving. So what do you say, new patterns are emerging. People may start have new ways to take fraud. So you cannot cover all the scenarios in that small data set. So this is where federated learning comes up, that you can actually do this in real time. So once you have this consortium or a group of people, or let's say banks who have let's say they have agreed, hey, we will work in this federated learning manner, we are happy to share the models but not the information. And what will happen that with months, they will, so every bank is basically generating new amount of information with new people, and they will every month they will have new kind of models there, so they will be up to date with the attacks or the fraud. So this is the scenario I'm talking about. So of course your point is that we have this data set, but then again this data set is just a kind of, I can say it, a toy problem. You can learn about it. Let's say you can use it for to learn some concepts, or use it somewhere, maybe, I don't know, maybe in some scenarios it may work, but not in in such scenarios where the banks, these big banks will not trust on data which people have already exploited. And of course, this is an open data set, right? And if I know this data set, I can always use patterns which are different from the data set has revealed. So a smart, fraudster can always try to trick the banks. So this is the scenarios, where data is changing, you're updating. This is where federated learning comes up, and that's why explained you the smartphone scenario, because every day we are generating so much data. You type so much, you are taking photographs, for example. So you are generating new information, and thus you need update of the model. You need some updation. If you are not updating, it's everything is done. Hey, this today is the day I stop using my phone, that's my data, then it's fine. It's valid and fine. You just say to the company, hey, this is my data, anonymize it. Or maybe if you are happy with anonymization or anything, just use it. Now everything is done, give the model back to me, I'm fine. But you will see, you will can't, it's not possible that you will not use your phone. In time will come, you'll start using your phone, and then you will see, hey, this model is not working well because the data is not, it's not been, the information has not been updated. So that's where the FL comes up. Did I answer your question, Sanjeev?
Yes, thank you, sir.
Yep.
Sir, I have a question.
Yep.
Recently, like RBI has like told like every like transaction and everything like should be like tokenization should be there. Don't you think like tokenization is like another way of collecting like again it's just the like replica of your card number?
Yeah, of course. Yeah, that's a good question actually. So yeah, tokenization is, as I said, this is not the only way to do the learning, as you said. So tokenization is let's say secured way of doing it. Definitely that will also work, because so first thing is that federated learning is still not very developed. It's still in a very research stage. So there are not many scenarios which it covers. And of course, RBI, for example, if you talk to them about, hey, I have this method called federated learning, I'm pretty sure they will discard it, because cryptography or crypto basically has been there much before uh, paradigms such as machine learning. So tokenization is more solid proof method, and that's why they are going with that. But the point here is that that is not the only way, because like in research, you have to try other ways also. So, and also you cannot always say that token is like foolproof. So it is a saying in security that something is secured until it is broken, or until it is hacked. So security is just give you multiple layers so that the fraudster takes time to break it. It can always be broken, but it takes more time. That's what about prime number generation. When we have so many keys, so that's what security is all about. So tokenization is more on the security aspect. but they are not learning actually. It's something there. I'm not sure they are doing some kind of learning, but what FL does it also brings learning along with security or some sort of security there. It may not be very good as tokenization, but there. But yeah, their research has been going on and maybe a time comes up that it works well as tokenization. Yep. So is Jayant, is it fine?
Yeah.
Right.
Yeah.
Yeah. Yes.
Hello.
Yeah. They mentioned. Please.
My question is also related to security. In one example, you gave the example to us like every mobile is computing a local model in that handheld device itself and sharing the models instead of data, right? So what about if a handheld device itself is malicious and it is continuously submitting a wrong or ill-formed model to the server, so that the averaged model that becomes inefficient or ineffective, so that everyone gets getting affected while it is receiving the averaged model. One particular handset can make suffer all the handheld device, right? By sending trading and sending a wrong model to the server. Is there any way to prevent it?
Yes, absolutely. And that's a very lovely question you have there. That, of course, it says possible that you can have this kind of malicious users who can upload, incorrect data. So there are, so this.
Sorry to interrupt. Not incorrect data. I'm trying to say incorrect model.
Yeah, you're right. I'm sorry. It should be incorrect model. So as you said, so just to repeat your question, that out of this 100 model, let's say 90 are what do you say spammers, and they have some just rubbish in their local data, and the model they are learning is also rubbish or garbage. And once you upload this to a server, if you have 90 rubbish or garbage models and 10 are good models, then of course the average will be more inclined towards rubbish, right? That's what you're asking. So how can we prevent this?
Yes, exactly.
Yeah, so that's a yeah. Sorry.
Yeah, is there at all any method to detect that whether it is a garbage model or a correct model? Whether one can detect that also. That is also a question and concern from my side.
Yeah, that's so first concern is it's a valid concern, and this is where the research in FL, one of the area where FL people are working on finding out these kind of malicious users in FL. So one way is to use so there was a paper in 2019 about similar problem, exactly the same problem which you are talking about. And what they do is basically they try to find out the drift in the data. So if you have so what happens is that you can always model the garbage with some kind of distribution. So they use different distribution, try to find out similarity if that model or the weights have that similar kind of noise distribution. Once you have a matching, they will try to filter them out. That's one way they've tried. I'm not sure how many what other research has been done in this area, but pretty sure the research is going on about using there was one other technique. I'm not sure remembering, but yeah. But the point here is that this is a very known problem in FL, and there have been multiple papers on it solving this problem. So you can have a look at it. Yep. So I'm not currently remember it, but exactly what was the paper name. But you can have a look at it. You will get some information there.
Okay, so it will be. It is very interesting to know that there can be a distribution of the models itself. Rather than we know distribution of data, but there can be a distribution of model itself. So
Yes, exactly.
Okay, that's interesting. And the second thing is, I'm just telling my concern. It's not the right question. It's like the model. When a model is getting trained from scratch, so nobody knows the distribution, right? So as you said that if most of the models coming are malicious, then the distribution one will. The distribution of the model will also be malicious, right? So it will basically think that the correct models are at the outliners or the malicious. I mean, if the distributions are created out of the received models of distribution. So, I mean, I'm not sure. I mean, actually, I'm trying to think how that can work. Actually, the model of the distribution of the models. So anyway, actually, okay, we will look into it later. I mean,
Yeah, no, it's I got your concern. So we need some more time to discuss that. But it's a valid concern, that much I can tell you. And there are not still many, foolproof methods. So if you are interested to go in that, try to read about some papers and maybe take up that project. That will be very interesting work. So yeah, that's a good thing is that you know the problem here. So that's how we research explores. You can explore the area. Yeah, thanks for the question. It was a good question there.
Thank you. Okay.
Sir, I had a follow-up question. So, like the problem that it is like if there are people who are sharing some malicious models with us. So let's say I have a Netflix account and I have some viewing activity. So I have some model weights. So instead of my model weights getting averaged out with everybody, including the malicious users as well, could it be that we do some kind of, let's say, clustering where there could be 10 to 15 people whose viewing activity on Netflix is very, very similar to mine. So we could only consider those particular users for averaging out the model parameters instead of considering everybody. So that way we can get rid of the malicious users.
So yeah, that's totally. So clustering is a solution there. So when I was talking about the distribution, so what they do is, and if you have a matching distribution, because noise have similar distribution, so you can cluster. And usually what happens is this noise gets clustered out there. So yeah, I think that's the paper name. Federated Learning with clustering, something like that is a paper name which does the similar thing you said. So yeah, that's a bang on answer to there. That once you know the distribution, the noise actually tries to have the similar kind of, and you can cluster them out. And with the users, they have different directions, because weights are all about these are all tensors there. So yeah.
Yeah, so like instead of taking everybody, so instead of taking like everyone who has an account on let's say Netflix and taking all their model weights and averaging out with mine, we can only consider some segment of users who have their viewing activity very, very similar to mine and only consider their particular model weights for averaging out mine. So that way I think we can do something.
This work has been tested. Even the code is available. You can try it out. Actually, let me show you some Federated Learning with clustering was there with clustering. There's a German guy who did that. Distance-based clustering. I think this was the one. Something about clustered Federated Learning. You can look in this. So these are the papers who talk about clustering. Yeah. So yeah, as you said, yeah, this case it's totally valid. What do you say? A way to go about it. But yeah, there are some limitations in that, because what happens is that you're not able to properly classify the clusters, because there will be always some haziness. So there are other methods which do some kind of hierarchical clustering, and some also employ adding some other noise into the data. So if you add noise to noise, you can get more patterns out of it. There are other methods also you can solve the problem. But yeah, that's the way to go about. Yep. Any other questions? Slide is up. Yep. So you can always contact me via LinkedIn or Twitter if you have any questions. That's one way to go about. I'm active on LinkedIn, and yep. I think that's all from my side. Any other thing? If any other question, we have at least like 7-8 minutes here.
Hello, sir.
Yep.
When you talked about performing the model training inside the consumer device or the customer device, so how do we make sure the computational resources are sufficient for computational resources available in the device are sufficient for training?
Yeah, that's a good question. So as you said, I think people also thought about it. That of course a smartphone doesn't have it. That much computation. It's just a Cortex processor. This kind of Snapdragon. So how can we? So first of all, it doesn't happen with all mobile devices. As I said Pixel phones. I think they have a good hardware there, but it's still not sufficient. But the way the training happens here in phones is using some kind of floating what do you say, they approximate the floating number. So suppose you have a floating digit in like 16 decimal places, they will make it down to 8 or 6 and then they do the training to make it faster. So there are some optimization happens, which is a different field altogether to happen, like training on edge devices. So it's a very important part of FL, but I in so I assumed here that we have some kind of technique to train it locally, but yeah, there are methods to like example floating point is one way, and also the amount of data also is not much high. So when you say computation, usually when we do training on our PC or machine, we work on large data sets, but in phones they work in very small batches. So that's one of the optimization they do. They make those batches size smaller, reduce the floating points to let's say 8 or 6 digits, and then do the training. So there is some loss of information there or accuracy, but I think it's the benefits are more than the losses. And of course, this, as I said, this happens when you do in the charging. Usually that's what happens. So because it also depletes the battery. So smartphones is one application, but federated learning, for example, in the VBank scenario, the banking scenario I gave, there it's happening in the server in the big machines out there. Yeah, but it's more challenging in the smartphone scenarios. All right then. So what shall we do? I think no more questions. Shall we close up, Andre?
Yeah, I think we don't have any. Yeah, I think we can record it again.
All right then. So yep, thanks all for joining the talk. I really appreciate the questions, and I'm actually happy that the questions were right on the point. So which basically means that people understood what I was talking about. And yeah, that's that's one as I said, try to also, because this talk was this SAB is all about interacting with the industry. So just wanted to make a point that just learning or knowing about machine learning is not enough now, but you also need to know about these concerns about data. Because finally, when you start working in industry, they will give you just data, and they will have to you will not do some fancy training of model, but you will start with data first. So that is my point. And I hope that this talk will give you new directions and awareness about what's happening in this industry. All right then, thank you all, and bye bye.
So thanks for taking time out for this.
Yep,
You
yep,
have
yep,
a
yep.
very busy schedule, so we really appreciate it.
Yeah, same here. Of course. I was there in few years back behind the scene, so definitely it's my responsibility here. So yeah, let me know, and please shoot me any question you have later and you want to do any research. I'm also open to research. Apart from my industry work, I also spend some time. So if you are interested, if you have some interesting problem to work on, just shoot me a message. Okay,
So,
bye bye.
have a good day.